There are 2 trillion galaxies in the observable universe. You need to know that the Milky Way galaxy has got 200 billion stars. Most of those stars, now we know, have planetary systems. We estimate there are something like 20 billion Earth-like planets, or potentially Earth-like planets, in the Milky Way galaxy alone. So if you're asking questions about what is my place in the universe is, you need to know those things first of all. It's a framework within which you can think. What is a black hole? I've been doing some work on black holes, and there's progress being made on that now, which I think is profound and exciting. So they are stars at the end of their life, bigger than the sun, more massive than the sun, but they run out of their fuel and they start to collapse because gravity squashes them. And if they're sufficiently massive, then there's nothing that can stop the collapse. And so they collapse, as far as we know, to a point, essentially an infinitely dense point. But they collapse to such an extent that there's a region around it from which light can't escape. So nothing can escape, and that's a black hole. They're surrounded by this region. It's called the event horizon. And if you go across that horizon, then you are going to the center. There's one way of thinking about it which is quite cool, which is that the time and space sort of flip. In the same way that we are going into the future now, so we're going to tomorrow. There's nothing we can do about it. We are going to tomorrow. In the same way, if you fall in across the event horizon of a black hole, you are going to the middle, the singularity it's called. So that's your future. Every line of your future points to the center of the black hole. We have now got photographs of them. So we have 2 photographs which are radio telescope photographs. One of the one in the center of our galaxy, which is a little one. It's called Sagittarius A star. So it's about 6 million times the mass of the sun. And they took a photo of one in the Galaxy M87, 55 million light-years away. That thing is around 6 billion times the mass of the sun. So if you took our sun, you can fit 1 million Earths inside, and collapsed it down to make a black hole, it would form a black hole when it shrunk to about 2 miles. And then that would form a black hole. 6 billion times the mass of the sun means you multiply that by 6 billion. So these things, the so-called Schwarzschild radius, is larger than our solar system. What you're seeing there is the emission from the material that's swelling around it. It's called the accretion disk. So you have material that's orbiting very fast, emitting a lot of radiation, and that's what you see. It's a flat disk, by the way. Think Saturn's rings. So this material is very flat. But what you're seeing in that photograph is the light rays being bent around the black hole from that flat disk. So that was a prediction from Einstein's theory, basically published in 1915. And you can predict that. That's what one should look like. And then just about 4 years ago now, maybe 5 years ago, for the first time in history, we get an image of one, and it looks like the prediction. Will human civilization expand? In science at the moment, space science, we have this debate a lot actually. Because of course, space probes like Curiosity that's on Mars at the moment, that's really cheap compared to sending people to Mars. And so quite often, the scientists who want to find out about the worlds will say, well, we should spend it on robots. We shouldn't spend it on people. I think crude space exploration is, in some ways, it's clearly true at the moment that humans can do more than robots, so we can explore the place better. It's about living and working off the planet, which I think is quite a persuasive argument actually. We've already industrialized near-Earth orbit, so it's already a multi-billion-dollar industry. Communication satellites and weather satellites, GPS, whatever. We're already up there. And so learning to live and work in space is, I think, a natural extension of our civilization. Plus the fact, if you talk to Elon or Jeff Bezos, they point out that the amount of resources available just slightly above our heads is vast. I remember I talked to Jeff Bezos actually once, and he thinks really simply. And he said, for example, in the asteroid belt, there's enough metal to build a skyscraper. What is it? Something like 800 stories tall, and cover the Earth in it, if you want. Now, we don't want to do that. But his point was that the energy from the sun is all up there. The resources are up there. So you could almost imagine trying to zone the Earth residential at some point in the future, to protect the planet and do your heavy industry off the planet, for example. And these sound like science fiction, except that now SpaceX and Blue Origin, those people have got reusable rockets. so suddenly the economics become sensible. I think expansion is good, and I think we will expand. And I think we will expand outwards because there's not much room left on this planet to expand. That's a whole different idea. It's not about gathering scientific information. It's about a frontier and all the benefits that come from operating as a civilization on a frontier, which we have lost on the Earth because there is no frontier left. And so, I like that idea. Life on Mars. There is no other planet we can go to other than Mars. You can't go to Jupiter or Saturn. You can't go to Mercury or Venus. So if we want to go somewhere and expand our civilization, it has to be Mars. And everything's there that you need. It's interesting, actually, because we know something about the history of Mars now, quite a lot about the history of Mars. And it's certainly clear that there was water, almost certainly oceans, rivers, and that water is almost certainly still there. So there's certainly ice. There may even be pockets of liquid water below the surface somewhere. Couple that with all the minerals and the resources that we know are there, and you have everything you need. So that's the thing about Mars. It's quite nice relative to everywhere else other than the Earth. So Mars is quite nice. Could life exist outside Earth? I think there must be. Even in the solar system, I would not be surprised if we find microbes on Mars, or on some of the moons of Jupiter or Saturn where there's liquid water. And the reason is, if you think about the history of life on Earth, so Earth formed, there was no life, it was a ball of rock. And almost as soon as it cooled down, we see evidence of life. So certainly 3.8 billion years ago, possibly even further back than that, we see evidence of life on Earth. So somewhere along the line, geochemistry, active geochemistry, became biochemistry on Earth. And we have some idea that if you get gradients of temperature and acid and alkaline and the conditions that are naturally present on the surface of oceans, then complex carbon chemistry spontaneously happens. So we know that life almost certainly began on Earth. I mean, the other option is it came from space or something like that, but it probably didn't. Probably began on Earth. So that means that at least here, that happened. And we know that the conditions that led to the origin of life on Earth were present on Mars 4 billion years ago. And we know that they're present on Europa today. So I don't see that there's anything special. Life is just chemistry. The idea that geochemistry becomes biochemistry is not fanciful because it happened here. So I think that given the same conditions, it would be surprising to me if the same thing didn't happen and that life begins. To test that is one of the great frontiers of science now. It's one of the great challenges, which is another reason we're interested in Mars. Because we know those conditions were there. We know there were what's called hydrothermal vent systems on the floors of oceans on Mars 3.8 or 4 billion years ago. So it would be good to know what I've said is right. And the way we find out is to find life or evidence of past life. The Grand Tack theory. You know that there's a theory called the Grand Tack theory. So it's very hard to explain the evolution of our solar system. When you do computer models of solar systems, you don't tend to get 4 rock planets close to the sun and 4 big gas giants further out. And one of the current best theories, and I say this because it shows you how lucky we might be, is that Jupiter, they tend to form these big gas giants and migrate inwards towards the star. So in almost all the computer simulations, just because you got this big gas giant orbiting in all the dust around the star, they tend to drop inwards. And it looks like Jupiter did that. So it looks like it formed and came in almost to where Mars orbits today, and cleared out the region around Mars actually, which is maybe the reason Mars is so small compared to Venus and Earth. But then Saturn was coming in as well. And in the computer models, the interaction between Jupiter and Saturn stops Jupiter coming in before it gets to the Earth, and they both get dragged out again to where they are today. And so, that seems to be one of the best theories for the evolution of our solar system. So what are the chances? The chances of that are so minuscule, tiny. So that's the thing I think about these rocky planets. In order to get a civilization on them, I think you need quite unusual solar systems, and that would be a guess. And you need quite unusual stability on the planet for billions of years. And that's why I think we might be quite lucky. The meaning of life. An answer would be, we are small, finite beings, which are just clusters of atoms, as we said before. They're very rare, but we understand roughly how they came to be, and we have a limited amount of time. Not actually, unfortunately, but because of the laws of nature. The laws of nature forbid us to be immortal. Immortality is ruled out by the laws of physics. But also, what's interesting is if you look at the basic physics of the universe going from the Big Bang to where we are today, then the physics is driven by the fact that the universe began in an extremely ordered state. So it was a very highly ordered system, and it is tending towards a more disordered system at the moment. And that's called the second law of thermodynamics. What we strongly suspect, and I would say know, is that in that process of going from order to disorder, complexity emerges naturally for a brief period of time. So it's a natural part of the evolution of the universe that you get a period in time when there's complexity in the universe. So stars and planets and galaxies and life and civilizations. But they exist because the universe is decaying, not in spite of the fact the universe is decaying. So our existence in that sort of picture is necessarily finite and necessarily time-limited. And it is a remarkable thing that that complexity has got so far that there are things in the universe that can think and feel and explore it. And I think that is the answer, if you want an answer to the meaning of it all, is that you are part of the universe. Because of the way the laws of nature work, you are allowed to exist. But you're allowed to exist for a small amount of time in a possibly infinite universe. What more do you want? When I see people who go, I want more than that. I want more. There must be more to it. What do you mean? The ingredients in our bodies were assembled in the hearts of long-dead stars over billions of years and have assembled themselves spontaneously into temporary structures that can think, can feel, and explore. And then those structures will decay away again at some point. And in the very far future, there'll be no structures left. So there we are. We exist in this little window when we can observe this magnificent universe. Why do you want any more?